Welcome to today's training. We're still going to be talking about object-oriented programming. And just before most of you joined in, I'd like to take a poll, go around and try to see um, on a level of on a scale of one to five, how much were you able to understand and follow the last lecture in terms of understanding what object-oriented programming is, understanding what classes are, objects, how you can create objects. So I want to take a poll from like one to five, and one being I didn't understand anything. It was just total, it was just going over my head, and five being okay, excellent. I'm on point. So we'll start with Obi.
Yes, I'll say four.
Okay, was good. Yeah, Constance, please try to be honest because if I know how much effort I have to. If I know how much like you understand it, I can put more effort to explain better. So don't be shy if you don't understand anything. So Constance.
It was a three for me.
A three, good. Ifine,
I think a five.
a five, good. Okay. Chinonso,
I think three.
three, okay. Sumbo,
Um, it was two for me, but most of it I would say was my fault because I was not fully paying attention in the class. But when I started paying attention, I understood what was going on.
okay. So I'm not gonna ask Daya because Daya was not in the class last week, except if Daya watched the video, which I'm not sure she did. Did you watch the video, Daya, for last week?
No,
No.
I've not watched it.
Okay. So cool. So we see we have like a scale from like five to like two. I think the minimum is two, and Dario is fresh of it. So I'm gonna just do a brief recap, and to be fair, the concept of object-oriented programming is not really one that, at least to me, it took me a minute to like really uh, it needs to like add up, and it really starts with you just understanding the like what it is. So, and I think most of you uh, do understand the idea, but I use the whole car thing. Uh, so you have your hands up.
Yeah. I have a
Okay.
question. Okay, so I did some learned some React. I know that in React, when you're designing, for example, a page, you group it into different sections. The heading, like the top part of the page, will have its own
Yeah.
design class. Then the text, the button, for example, has its own class. Is that what object-oriented programming is?
Yeah. So they are also okay. Um, Let me put it like this. React is not object-oriented programming, but they do adopt the concept of classes. You can, however, program in an object-oriented way. Um, so typically, um, how would I put it? So the concept of classes and creating objects is the same, no matter what language. So React, you create a class. From the class, you create an object. That's the same. It's the same idea. But programming in an object-oriented way, you have to design your software in a certain kind of way. Do you understand? It's a concept. It's a way of programming, and you have programming languages that are built to support that. Even if you try to force yourself to do it in a different kind of way, it's a lot harder. But React, you can program in an object-oriented way whereby um, you create classes and your classes inherit from other classes and you share objects, but then maybe the building of the interface would just not really be object oriented, but the way you transfer data might be. You understand? But we can talk on a separate on a separate situation, so I can explain it better to you. And but I also hope like as we go on, um, you understand it better. But also you see similarities, right? So if any of you is also playing with other programming languages and you have questions from there, just ask. But in theory, the concept of classes and objects is the same everywhere in all languages that you use. So that's why I typically feel if you know one programming language, you would understand the other. The only thing you have to learn is syntax. So yeah, the ideas are the same. So the point is, right now we are in this example you're seeing here. So just to give a quick recap, right? So we talked about object-oriented programming language, and we talked about um, what classes are and what objects are. And we use this example of a car and an actual car. And in Java, you drawing out a blueprint of a car is actually what we refer to as class. And from the blueprint, you can create multiple cars that have different properties. So you see, this is a blueprint of this car, but from this blueprint, you're able to produce a blue car and a red car, and even some funny or slick artifacts because you can see now like this blue one has a yellow stuff in the front and this one doesn't. So even though they're coming out from the same blueprint, there are things that are slightly different or slightly unique to a given car. Um, so also I showed you guys how to create objects. So this part is quite important. Let me see. This is a different project. Let me just switch. Give me a minute. Let me see. Where's the recent project? Superhero. This window. Okay. So this was the example we had last time of the car. So this is us setting up the blueprint. So we create a car class. So there is no way in Java that you're going to write a program that you're not going to start with a class. It always starts with a class. So already it's forcing you to program in an object-oriented way. That's not the same in Java. You understand? I I'm not sure. I'm not sure it's the same in React, for example, except you're going through TypeScript. But Java forces you to program in an object-oriented way because you cannot do anything without starting with a class. Remember, even before we started talking about object-oriented programming, we all programmed the main method inside a class. So you already have to create an object. And then from the object, we now have the main method, and then your program starts. So why am I saying that? You have programming languages that are built to support object-oriented programming, and Java is one of them. So we also have an example here where we have a car object, sorry, a car class, and this car has different properties. It has property make, model, year, color, and wheel. And the wheel here is also another object. So this has, just like you have in the picture here, this drawing. So we have the car is as a whole, but the car is made up of different objects. So you have the object of door, the object wheel, the object headlights. Because if you don't make it that way, you're gonna have something like this. Let me get a picture again because I think pictures actually drive the message home. So let's say car, let's do toy, let's say plastic toy car. Let me get one like, let me pick up one that is very, very much what I think. So let's take this one as an example. I don't know if we can still get it. Okay, that didn't work out well. Or did it? Open new tab. Okay, so take this car for example, right? If I told you to change the door of this car, that's crazy because you have to bring a knife and tear it out. And in fact, you tear it out and put in another door after you tear it out, the car will be so ugly it will not look the same. Or if I ask you to change the bonnet, or I ask you to change the windscreen, you have to literally destroy the car to change it. And even if you got another one, and now so that it will not look the same, it will not look as fresh as this. So this, what you see here, is just like if you have to take it to programming language in Java, or programming software in Java, it's just one big chunk of function of code that is not created, is not designed in an object-oriented way. But in our example, we didn't do that. In our example, we said, okay, the wheel is going to be a separate object. We can go as far as we want. We could be the wheel. We're going to have an object wheel. We're going to have an object door, four doors. We're going to have different objects. And that way, if we have to change one of the wheels, all we just need to do is just get that wheel and change it. We don't have to tear out anything because it's not like glued to it. So, and we also talked about if we run it, for example, I think here we did the whole thing where we created a new instance of an object. So for you to create a new instance of an object, which is the point where you move from your class, which is this drawing, to an actual object, you have to use the new keyword. So you have to say new, um, like you have to say car, or actually the name of your object or of your class, and then you give it a variable name is equal to new car. And this will trigger your constructor. So, and remember, your constructor is every class. Every class has a constructor. And if what happens is when you call or when you instantiate your class, remember you instantiate your class using the new keyword. So if you say new car, that means you create a new instance. Now you've actually manufactured a car when you use the new keyword. So you've actually created it. So the first thing it does when you instantiate or you initialize a class is it goes and tries to run that class through the constructor. And the constructor is like the starting point your of your class. And constructors are very different from methods because if you want to define a constructor, you just say public and then the name of that class. So this is the first place when you run this class. This is the first place the class is going to look for when you initialize it. And you see here the constructor we have programmed in such a way that when you initialize it, it forces you to give some initial values. And these initial values is going to be what we're going to use to set the state of this car when it's initialized or when it's manufactured. So you see, it forces you to give the make, the model, the year, the color, and the wheels. And these wheels are actually their own separate objects. Great. So that's just for a recap. So one of the things I like us to concentrate on this on today's training is okay. We want to talk more a little bit about access modifiers, and we're going to talk a little bit about methods. Um, so first of all, before we talk about that, I have a question. Is it possible that you create a class like we have this class car, right? What do you think? Is it possible to get rid of this constructor? If I took out this constructor now and I save this, would this still work? So raise your hand if you think it's still going to work if I run it. And what I mean by if it's still going to work is if I initialize it, can I create a car? Can I remember from the class we can create an actual car? Can I actually create a car object without the constructor being like I just removed it right now? Okay, so we have two people. Constance, you raise your hand or you put your hands down now? Which put your hands down? Okay.
You put your hands
I
down
put
now.
my
All right.
hand down
So
again.
we're gonna go with Ifine. Ifine says it's still gonna work. So Ifine, tell me why is it gonna work, or why do you think it's gonna work? Because remember, we sorry, because remember I said
Because
The
the constructor,
constructor is the gateway or is the first thing the program, when you initialize, the first place it goes to look for, like, okay, there must be a constructor here, and it must have a constructor. So why is this still going to work?
okay, like if we have the make, the color, and the
So
model
if you have the
initialized,
make,
the code
but
is
we
still
don't
gonna
have
work.
it initialized. Look at it. It's all, there's nothing in it.
Okay, the code is gonna, but the start engine is not gonna. We
Okay.
need those
So my
values
question
from
is,
the
will this
to be
code give us
initialized.
an error, or would it actually create an object for me if I use the new keyword? So let me go back to this code. So if I do this, um, no, let me just take this out, because right now we've removed this one, right? So I'm just gonna comment this out. Comment this out. So if I did something like this, car, remember that's how we create a new instance. Now we're trying to manufacture a car. If I say car is equal to new car, and I came down here and I said car2 is equal to new car. Will this work? So this is us creating a new instance of a car. So when we do this, we get our objects. That's a car actually gets produced, and now we're going to use that car to start our engine. So my question is, will this work? If
Yes, since a string
so, which string are you talking
can
about?
be nullable, not like a number, it's gonna work.
Color, okay.
The name, the color,
Okay, but what about my explanation of
and the
saying
model,
there must be a
they
constructor,
make.
but there's no constructor here. So how is it going to work? Because the first thing, if I go here, the first thing that he's going to is supposed to look for when you use a new keyword is it goes to find your constructor. The constructor is always how it gets into your object or initializes your object to be like, okay, now I can run this. But we don't have it. So why do you think it's still going to work?
A constructor can be omitted. You use it when you want to, when you want to initialize your object the first time you're creating it. You can still initialize your
Okay.
objects using
All right.
getters
So
and setters.
great. So let me break it down. So there's a lot of good answers or correct answers in your explanation, but you just have to align it properly. So that's what I'm going to help you do. First question, if I got right, is that this code will still work. So let's give it a try so you see. If I run this, okay. So the problem is just this part, but let me just comment this out. So let's see. Are we still going to be able to create an object? That's the question, huh? So let's run it again. So yes, we were able to create an object. Let me put breakpoint so you really see we were able to create an object. So I'll put my breakpoint here and I'll put my breakpoint here and I'll run it again. I'll run it on debug. So you see my debug is here, and now I'm going to step over, and you see we have a car object. Our car has been created. Yeah. Whoa, whoa. So you see our car object has been created. And if I go to the second one, you see our car2 object has been created. So the question is, okay, guy, you just told us that there must, I use the word must, be a constructor, but there is no constructor here. Yeah, so the answer
So
is,
a constructor
when
is
you
there
create a
to
new
create it or
instance
not.
in Java, if Java looks at your code and does not find a constructor, it will create one for you, but you just will not see it. It's in there because it must have a constructor. It's a must. You understand? So when you see a code that doesn't have a constructor, it's still gonna work. But the only reason why it's working is because Java will create a default constructor for you. Remember that when you run the code, Um, remember the whole process we learned that it changes, it turns into bytecode and all of that. When it's changing to bytecode, it creates a constructor for you behind the scenes. You don't even have to think about it. And that is one of the flexibilities of Java, compared to other programming languages of old, because it gives you some of those flexibility. But the only difference is that if you want certain states to be initialized when you create a new object, those states will not be initialized anymore. So, for example, you see, I put a breakpoint. Now, take a look at this. So we have car one, but look, the make has no value, model is new, year is new, color is new, wheel no. That means nothing was initialized. So this car, when it was created, has nothing. It's just a blank nothing. We don't know the make. It's just like you just take mod and you just fold and just do something. We don't even know what type of car it is, because when you were initializing it, you did not set most of these parameters. So it doesn't mean your code will not work. It doesn't mean it's wrong. It doesn't even mean that you must have a constructor in your code. But you, as the programmer, need to know what you want to do, or you need to know, what do I want my initial state to be? Remember last time we talked about initial state of a lamp. So you that created a lamp, you are the one that's going to think like, okay, if someone plugs it, what will be the initial state? It could be the initial state is on. Oh, then you make it on. It could be the initial state is off. You make it off. You understand? So this is not wrong code. You understand? It's not a must that you must put the make, you must put the model, you must put the year. The point is, you that is designing the software have to ask yourself, when people create this object, what will be the initial state? Just like a car designer said, thought about it, that when people use this blueprint to print, to create a car, there must be, he's the one that thought of the initial state. He's the one that said it should be blue, it should have yellow thing, blah 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 blah. So he's the one that defined that or figured that out or said this is how what you can do. So the bottom line I'm trying to point out, because for those of you that is doing C sharp, I know Constance is doing C sharp. Some of you might eventually go do Java as an take Java as an exam. If you have questions like this, it will definitely run well. Now, it's a different question if I ask something like this. Let's go back to our car creator. If I asked you, will this code work? So I'm going to put a comment on this one and open up the first two. So you see, in this second one now, we have a constructor that is passing in values. See, it's passing in Ferrari, all these values. And if I asked you, will this code work? See, even IntelliJ is telling you it's not going to work, because when you look at this code here, it has no constructor that is accepting values. Look, this constructor is accepting all these parameters. So definitely this will not work, because when you go into your code, you'll be like, okay, where's the constructor? I'm not seeing any constructor that is accepting value. So if that were to be my question, then the answer will be no, it will not work. And even IntelliJ is telling you, it's not going to work, because I cannot find a constructor that is accepting these parameters you're trying to give. But if I were to remove all the parameters now and just make it empty, it's going to work, because this one Java will create for you. So Java is going to be like, okay, I have a constructor. I have to create an instance where there's nothing, there's no parameters injected. Oh, fine, that's easy. I'm going to create it myself, since that person didn't create it. But even if you created it yourself, so how can you create a constructor yourself that supports this? It's also simple. Just do something like this. Just come here and say, wait, let me. So I'm going to comment this out, because we're going to need it again. So now there's no constructor. So you can now say, do something like this: public car, and then no parameter, and that's it. You can leave it empty. And this is what you call a parameterless constructor. So this is a constructor with parameter, and this is a parameterless constructor. So this is exactly what Java will create for you. if you did not create it yourself. So now, if we run this code, so you see here we create a new instance. If we run this code, it will still run with no error. You see, there's no error. So what happens is Java went into the code, found a constructor, and it was a parameterless constructor, and it just created it because this you must is a must. You must have a constructor. And if I remove this, if in your Java question, if they asked you if when an instance was created, did it still have a constructor? Yes, it still had a constructor. The only difference is Java created it for you. And what the Java create for you is exactly what you see here, a parameterless constructor. He just did it under the scene without you knowing. But the bottom line is all classes and objects have a constructor. That's one. Is there any question? You guys have any question? All right. No. Now let's move to the second part, which is um, access modifiers. So I'm gonna destroy this stuff I'm doing. Let's clean it up because I wanna like teach you guys while doing. So this is a class. Does this class have a constructor or not? If you think it has a constructor, raise up your hand. Okay. So so why do you think it has a constructor?
Because you said this is how
Okay.
to create a
Who else
constructor,
thinks it has
public
a constructor?
class, and the name you want to give to it.
Okay. So to correct that, so this is how you create a class. This is not how you create a constructor. This is how you create a class. So we just have a class here. And the question is, does this class that I've created have a constructor? Do you get it? So remember, the syntax is different. I can understand why it can be very confusing. If you see a syntax that has class, public class, now you're creating a class. This is what you're doing. You just created this blueprint. But a constructor, like I was trying to say, that is where that's like the gateway to your class being converted to an object. So if your class is going to move from this drawing to this actual thing, it goes through a constructor. It must go through a constructor. And I also said every class must have a constructor. But if you look at this, my class, does it have a constructor? So if you still think it has a constructor, raise up your hand. Like this one I wrote down. Okay, good. So the answer is no, it doesn't have a constructor. But I can put a constructor. So let me just write it so you see the syntax here. So to create a constructor would be public car and open close brackets. So now I have a constructor. And the constructor is very important. You see, it's just public and the name of the class, which is the same thing. It must be the same capitals, the same whatever. So please remember, it's just the access modifier and the name of the class. Once you see this, then this is a constructor. So let's go back. So now here we have a class. We don't have a constructor. Now, if my question were to be, will this code still work if I ran it here? Would it still work? Which of you think it's still going to work, or would it give me an error? If you think it's going to give me an error, please raise up your hand. If I run it, remember this is where we create an instance of this car object. So got the car, we created a class here, and here we didn't put anything in it, and we just came here and we are trying to create a new instance. Let me get rid of all of this, so it's not confusing. All of this, let me get rid of everything. So if we run this code now with it, if you think it's going to give us an error, raise up your hand. Okay. Obina. Okay, Obina, you feel it's going to give us an error? Okay, good. So I'll take it that the rest of the people that didn't raise up
Yeah,
your
because
hand
there's no constructor.
um, um, feel it's not going to give an error. So I'm going to ask Dio, since Dio did not raise up her hand. Dio, why do you think this code is not going to give us an error? So this is the there's no answer is wrong, eh? So just give it a shot. So this is the class, and OB is right. We don't have any constructor here defined. And here we are creating a new object, a new instance of it. Why is it not going to give us an error? Dio, give it a shot. From what you've heard so far, if you're mute, okay. So maybe Dio is not physically here. Okay, so we'll give it another try. Sumbor, you also feel like it's not going to give an error. You want to give it a shot? Why do you think it's not going to give us an error? So let me go. Yeah, but
Um,
Obi's argument is it's going to give an error
because
because there is no constructor.
there's nothing
And he's right.
in.
Look, I'm looking at it. I didn't put any constructor in it. So is Obi right, or do you feel Obi is saying it's going to give an error because there's no constructor? You're saying is not going to give an error, or you support Obi now? And if you think it's not good, okay,
To be honest, I'm really
okay.
unsure.
So you're supporting Obi.
But
So you're on team
looking at
Obi.
it, it
All right, let me put
probably
it.
will give an error.
So I'm going to come back to you. I think you feel it's not going
Yeah.
to give an error because you didn't raise up your hand. Why do you think it's not going to give us an error?
Yeah, because the
Thank you
last
very
time
much.
you
So
explained that
please remember that.
even though you don't create a
So Obi,
constructor, Java creates a
the answer is
constructor for
it will
you.
not give you an error because when you run it, Java is going to come here, look, oh, you don't have a constructor, I'm going to create it for you. So let's give that a try. I'm going to run this and you see. Look, there is no error. And we can even put a breakpoint for you to really see it created an object. I'm going to run it. See it stop there. If I step over, if I go to the next line, look at it. The object is created. It just says it has no fields, but the object exists. Look at it here. Car. So the answer is it will create an object for you, even though I did not create it here. So that's one. Now, secondly, we'll move now to access modifiers. Access modifiers, we've been seeing them the whole time. It's this public stuff. Public, we have public, we have private, and we have abstract, for example. So I'm going to give a list of the different access modifiers we have. So we have public. So this is a keyword, right? Public. We have private. We have protected, and then we have yeah. Let's keep it to this one first. Let's stay here. So what is public? What we've been using it like even when we started our first program, when we wrote our first programming our programming exercise. Look, it starts with public. We said public class. We said public static void. Uh, what is this actually? So that's where we want to come in because when you start designing in object-oriented way, you have to start understanding what those things are because they can be very powerful. Um, Obi, let me see. Obi, you still raising up your hand, or it was from the last one? Okay, great. So, so the question is, what are these access
No,
modifiers
no, it's not.
and what do they do? So, for those of you who probably read up on this, on the stuff I gave last time, I told you guys to read up on object-oriented programming. Did any of you come across the answer to this question? What is public? What is private? What is protected? And how do you use it? Or what does it do? Let me put it that way. And if you did, please raise your hand. Or if you can try, just try. It doesn't matter. All right, Constance is gonna try. All right, go. Okay.
You use public classes. When you use public classes, it can be accessed by other classes. But if it's private,
Okay.
then
What about protected?
other classes can't access that.
So Constance is absolutely
Not
right.
not right.
But I think it would only make sense if you
I
really
don't know
see
what
it.
protected means.
What she's saying can be accessed by other class. So let's take a look at what we have here. So we have a class called car, and we have another class called car creator. Do you guys know? Uh, do you guys know what the difference is between these two classes and what they do? So who can give me? Who can try? I want you guys to really try. What does this car class do, and what does car creator class do? So let me create some space so you guys will see. So first of all, take a look at the car class. Okay, and then we're going to take a look at car creator class. What do they do? And are they the same class? So first, let me go with Obi, give it a shot. Give it a shot. I can, if you want me to go to the car, you let me know. Or if you still want to see it, I can click back and forth. Just let me know. So, what do you? Sorry? Yeah. First
Let's
of all, okay, let me ask the question, then you answer. This car class and the car creator class, are they the same? Are they the
create
same
okay.
class? No, no, no. Let's keep it simple. Let's keep it simple.
One is
Are they the same?
um one
Car
is
class and car creator class, are they the same? You know, when
because
something is the
one
same,
is
it
the
means it's a
object of
complete copy of, is the exact copy of the same thing. Are
okay.
they the same? Yes, it's exact copy. Like, okay, are they the same? Sorry?
Like a duplicate.
Of course, they're not the same because one is called car and one is called car creator. So they are
Not
two different classes. That means when you
they're not the
initialize
same.
them, you're gonna have two different objects. You're not gonna have the same object, just two different objects. So first, we've established now that they're not the same. Now, since they're not the same, what does car do, and what does car creator do? So what does car do? I'm sure you can now. What does it do? Okay. So yeah,
Um
exactly. Object
car
identifier because
create
there's nothing. It does
create
nothing.
a
Look at
class
there's nothing inside it. But the only thing you can do is you can just create an object from it. It does nothing.
object
There's
from
nothing
it
inside it. We've removed
created.
everything. So this car class, the answer is it does
Yeah.
nothing, but you can create an
Yeah.
an object from it because yeah, because it's not going to give you an error. Then if we go to car creator, what does this one do? If you look at it. Okay, stop. Let me try let me try Constance. Constance, what does this car creator object do? Okay. Okay.
Um, well, it
Okay.
has a main method inside of it.
Let's try Chinonso. So it has main method
Yeah,
inside of that was your answer?
I don't know.
Chinonso, what do you think it does? So you said,
Um,
can you repeat yourself
the
again?
car creator is where the constructor is, and that's like the gateway to, to opening it.
Okay. Okay.
The
All right.
car
Keep that
creator
in
is where
mind
the
as well.
constructor is, and that's
Sumbo,
like
are
the
you are
gateway
you are you seeing the screen or your screen is
in
still
the
frozen?
opening way.
I think Sumbo's screen was frozen a minute ago.
I'm trying to restart it, but
Okay, so then we'll skip you for
um,
now. If fine,
yeah,
what
I can't really see the screen on
is
my
this
phone
car
because I'm using my
creator
phone and the
doing?
computer
What is it?
is
We've identified
restarting.
that it's a different. It's not the same as the car, but what is he doing? What's his job? Okay, so break it down. I think We're using that word instantiate. Please,
It's
that word
the car
instantiate is
creator
very
is
important. You guys should
instantiating a
get
new
used to
car
it.
object.
You need to know what it means. Like, so is either you hear instantiate or initialize. But for now, if I break it down better, try so that we know what that word initialize mean or instantiate.
Uh,
Good. Okay. If
we're creating a
we
new car
don't
object
have this car class,
with the constructor method of the car
that's one thing,
car
right? I
class.
understand. So if you're right, but what if I say if we don't have this car class, will we be able to run our car our car object? We'll be able to start it? Yeah. No, the car creator class.
You mean if you don't have the car creator class or the car
Yeah.
class,
So the point, let me now break it down. Thank you, fine. So let me break it down.
you
So the
don't,
job of this
the
car
car
creator
creator class,
class
if it has a
is
main method, it will run, but
to be the
since it doesn't,
gateway
it
to
will
our
not.
program, to be the gateway to our car software. Because if you look at our car class, it has no main method. So every program you write needs to have a gate, which is this main method. So we have a car creator class that has a main method. Okay, when you now go through that door, when you go through the gate, what do you see? It says, oh, now when you get through the gate, you have to manufacture something. You have to create an instance of a car. But remember, this car is not in itself. This is not the same class as this is another different class, which is here. So it says go. It's saying go and look for a car class and create an instance of it or create an object from it. That's what this is doing. So the moment you do that, a new car gets manufactured. So two things I want you guys to understand. First of all, the car creator class is the starting point of our program. Because my question is, what is it used for? Without the car creator class, we cannot run anything because our car has no main method. So the car creator class is the starting point of our program. Without it, because it's the only class that has the main method, and it's the only class that through the main method is calling our car. So we need a gate. Remember, so through the main method, we start. Now, okay, now we have started. What do I do? Now we've got through the main door. It now say on line 7. It now says, oh, now that you've got into the main door, please go and create a car object. So it has to now go and start looking for a car. And yeah, it found it. It's a class. Yes, I can create an object from it. Now remember how we get in here. We're talking about access modifiers. Now, what if I said this car has a property, public color sorry, public string color, which actually defines the color of this car. You see, it's a property. This is not a constructor. This is not a constructor. This is just a property. Remember, every object has a property. My properties, if you look at me, some of my properties, I have a black skin. My color, the color of my skin is black. Um, uh, my beard is black. Um, yeah, you can get features that you be like, okay, this is even though these same features are across every human being, but these are the properties of Darwin. Darwin is a dark skin, his nose is wider, or whatever, how you want to think about it. So that's how you have to think about it. So the property of this class, it has a color. You can even go further and say we now added another one, public, and we're gonna say what other properties can we think of? Help me out. What properties could it have? We could also say wheel, because remember we created a wheel class here. So wheel is also a property. Or say yeah, wheel. I would say wheel one. So let's just leave it at these two things. So remember we were talking about access modifier, and here I made these properties public. And Constance says when it's public, you can access it from other classes. So remember, we identified that the car creator class and the car are not the same class. So that means a car creator class is another class. It's a different class. And that's true because the different class and that different class, its job is to create a new instance of our car. So it's just when we run it, it creates a new instance. And now let's see the magic. So Constance told us that if you make it public, that means it can be accessed from outside that class. That means you can set it, and that means you can get it. That means you can set a value to it, and you can also get the value that it has. Now let's give that a try. So we have a color and we have wheel. So let's use color first. So now, since we created a new instance here called car, we can now say car dot. Check this out. Color. We can actually access color. So when we click on it, it now becomes car dot color. We can now put whatever we want into that color. We say equal to blue. Since it's a string, we can even go and access the other property, which is will1. See, that's will here. This will1. We can access it and also give it a value. So since it's an object, we can say new will, and oh yeah, this one also has like parameters, but we're going to create a parameterless will for our test. So you see, we have the will is saying you must give me the parameters, but I want a parameterless version. So I'm just going to come here and add another constructor, which we're going to talk about because the question is probably going to come in your head. Is it possible to have two constructors? And the answer is yes. So I have another constructor here, and that's the one I'm calling, which is parameterless. So, but the bottom line I'm trying to say is from creating a new instance or initializing our car object, or we created an object from our car class, which is now this variable car, we are now able to set the color directly. So now we can test it. We can now say system.out.print, sorry, print ln, and we can say give us whatever is in car.color. This is how you access that property. So when we save it now and we run it, we'll see now that the color is blue. But guess what? This blue, we are setting it from outside the car class. So in the car class itself, yeah, there was no value. But from outside the car class, which is the car creator class, we created an instance, and from there we started assigning the colors to it. And we are only able to do that because this property is public. When it's public, you can change, you can get it from outside the class itself. Now let's go to the other one. What if we made it private? So we're going to try that again. So now I'm going to get rid of this. I'm going to get rid of this. And we make this. We're going to save this and we're going to make it private, right? So if we made this private, what happens? Private, private. So guess what? Now that it's private, we're doing the same thing. We created a new instance, and now we're like, oh, yeah, I want to set the color. And guess what? Once we put a dot, check this out. We can't even find it. It's not here. IntelliJ is telling us, bro, I can't see anything. Okay, you're not like, okay, fine, you can't see it. I know it's there, so I'm gonna call it out myself. I'm gonna say color, and I'm gonna say it's equal to, and I'm gonna say blue, and I'm going to close it. And even though intelligence is telling me, guy, I didn't see any color. I look at it, it's there, color, but the only thing is private. And then you're like, fine, I know it's there, and you run it anyway, and guess what's gonna happen? See, you get an error, and it says color has private access. That means you cannot access it from outside the class. If you were inside the class of car, sure, you can access it. You can have a method that says, let's create a method, right, and call it public show color, and I can say I can do something. Sorry, I'm gonna make this a void, which I'm gonna explain all of this to you guys later. And we can just say system dot out dot print and color. See, this is inside the class. So you see, I can access it as long as I'm trying to access it from inside the car class. Look, I can access it. But from outside the car class, no, I can access it. And to show you that I can access it from inside the car class, look now, I'm going to call this method that says show color. I'm going to call it from out here. I'm going to change this now to car.showColor. And because it's a method, which I'm also going to explain, if I run this, see, it says null, of course, but let's put a value because actually it is null. So let's give it a value. So I'm gonna say car. I'm gonna come here and make it. I'm just gonna say equal to pink, pink. So if I run this now, car creator, and I run it, see it's gonna be pink. That means the show color was able to access the color class from because it's inside. It's you're trying to get it from inside itself. Look at color, just called it. But if you're trying to get it from outside of the class, you cannot do that. If you're trying to get it from here. But look at what happened again. I created a method called showColor, but I'm also able to access it from outside the class. And why? Did you see what happened here? I used the public keyword. I wanted to call this method because this method prints out color, showColor, and I used the public keyword again. Check this out. Here, sorry. Then I said car, which is the name of the variable, dot color. What if I made it private? What if I said private? What if I did that? Check this out. I can no longer access it. It's telling me show class has private access. So simply, if you just think about it, private is a keyword that is used to hide properties, methods from outside classes. Outside classes will not be able to see it. Outside classes will not be able to use it. So typically, you as the designer have to be like, okay, I don't like this is mostly convention, right? In most cases, private. So in most cases, when you have properties, it's a good design principle not to make it public. Because if you make it public, other programmers, when you're a software engineer, you're not the only one working on your code. Everybody will be working on your code. You have colleagues that will be working on your code. So it's typically not a good idea to make it uh, public, even though you can make it public if you like, if that's what you want. But a good design practice is not to make your object properties public. You make it private. And if you want to change the value that is in here, of course, we've seen that you can change it from a constructor, but you can also change it from something we call setter, and you can also get it from something we call um, uh, a getter. And what are setters and getters? Setters and getters are methods. Methods are actually what you it actually a block of code that you put in your class that performs an action. So remember, we have I'm gonna make this public again. So you see, I have a method here called show color, and it performs an action. It prints out something. And how do you define a method? Now, a method comes with first the access modifier. So if this is a method you want outside classes to be able to call, definitely you must put a public. You must make it public. So it starts with an access modifier. The second one is a return type, and the third one is the name of the um, of the method. So I think I also have this in here somewhere. So we call them, yeah. So yeah, here I use functions, but I think I should also add method. So for those of you that are programming React, that are programming JavaScript, you hear the word function, function. It's the same thing. A function and a method is the same thing. In Java, we mostly call it methods. In C Sharp, we call it methods. In JavaScript, they call it functions. In React, they call it functions. They are the same thing. It's a block of code that performs a specific task, and they are also defined within the class that can invoke it. So if we go back to the code, we'll see that this block of code is performing a specific action, which is it prints out the color of the car. Then we have different types of functions or different types of methods. Let me not use the word function. Method. Let me stick to methods. We have different types of methods. We have methods that does not return any that has no return type and has no argument. So you see, this is an example of a method that has no return type and argument. And how do we know that? When you see the word void used, it means that this method is not going to return anything when it's called. So I think for you to understand this, you need to see the opposite of this. So let's see the opposite. So we're going to create a method now that returns something. So we're going to say public. Um, we want this method to return to us. Let's have another property. So we're going to say private string type. So this will be type of car type. So say this is we'll just put it. This is a Volvo, right? So it's private. Of course, we cannot access it. So we're going to create a method that's going to return to us the type of this car. And since we want to return the type of this car, I mean the type of from this property, we want to take whatever property is in this type and I want to return it. I'm going to ask a question now. What return type then should we give it? Since this is what we want to return. We want to return whatever is being put into this type. What is the return type we must give this method? Let's start with um, Sumbo here. Sumba, are you here? Yeah, Sumba is usually busy with the kids every now and then, so maybe she's not here. So we're gonna start. We're gonna go to Chinoso. Chinoso, what? Look at my question, eh? Just think about it. I want to create a method that will return to us the type of this car. So it's going to get this type and return it. So if we're going to be returning this type, what is the uh yeah, oh my god, I think I'm mixing it up. Let me change this name so I don't confuse you guys. So instead of type, I'll say model. Yes, this so fine because the reason why I'm changing is because the word type has a meaning in Java. Remember we learned type. We had type string, we have type int, we have type char. So so that I don't confuse you guys. So let's change this to model so that you understand when I use the word type, I'm talking about type in Java. So we want to return the model. So we want when we call this method, it should give us whatever is put into this inside this model. And at this point, what is put inside this model is Volvo. So what do you think should be the return type? What type should we use? Or I'll say will be the return type of this function of this method? What do you think? Since this is what we are returning. Okay, that's a very good question. Now we only use void when we are not returning something.
Um,
So if you look at this,
okay,
we're not
won't
returning
void
anything.
work
We're just
again
printing something.
since it already worked with the color?
Okay. So the answer is remember what are the types we have in Java? Thank you, Chinoso. And it's good I'm asking this
Okay,
question. It's okay
so
if you don't
maybe
get the right
use
answer, but
public
it's just gonna
model.
trigger you or make you think. So remember the types of the types we have in Java. Can you remember some of the types? We have. I'm gonna start. We have string. Obi, what other types do we have? We have ints. Chinoso, can you remember any other type? We have char. If I can you remember any other type? I can't even remember. We have boolean. Good. We have
We have
long. We have
it's
float. Right. So what I'm asking
We
is
have
actually
char.
that I'm saying, what would be the return type if you want to return the name of the model?
A bullet.
So technically, it will be string. Beautiful. So it's going to be string. You're saying I want you to return a string because I'm going to use that. Then after that return type, because we are creating a method, huh?
String.
After that return type, then you give your method a name. or you give your function a name. But like I said, in Java we use the word method instead. You give it a name. So it's normally a good idea to give it a name that you understand. So in this case, I'll give it a name of um, show, or say show model name. You can give it any name you want, but I want my name to be descriptive. So when I see it next time, I know what it's doing. So the name I'm giving to it is show model name. So remember, it's a block of code. So that means we have to put something in here. And then that means we have to return a string type. When someone calls this method, it has to return a string. So that's why it's giving me an error here saying, bro, you have not returned anything. And for you to return something, you have to use the keyword called return. And then you call the name, you use the name model because that's what we want to return. And that's it. And we close it. So these are two different objects. So let's even push a little bit more. Let's say we're gonna add another one and say private uh, year, or say build year. Build year. That's the year it's built. Sorry, I'm gonna use build year. I want it to be an integer. I'm gonna say is equal to 2024. So if I have to create a method that returns a build year, it's going to be this very similar. I'm gonna say public. What will be my return type? Who's gonna help me here? Constance. What will be my return type? Constance. Exactly, because I'm returning a build year, which is actually um, of type int. So I'll say, and I'll now
And
put something like show. Remember, you can call it anything you want,
And
but I recommend give it a name that describes what it's doing. So I'll say show build year. Then what will be the next thing I'm gonna do? Sumba, are you here? Okay, Sumba's not here. So Obi, what is going on here? What am I gonna do here? It's giving me an error. What should I do? Yeah, look, it's giving me a squiggly line here. It's like, okay, because I want to return build year, and I said the return type is int. So what would be the next thing I'll type?
There's an error.
Exactly. Return, and then what? Build year, exactly. And remember, build year is private, but because I'm calling it from within
Um,
itself,
that be
it's not a problem.
return
It can
and then
access it.
return.
I'm calling it from within the same class.
Uh,
So now,
the build here.
remember, show build year and show model name are both public. Now, from outside that class, I can access it. So I'll say car dot build year. But guess what? Because this stuff is going to return something, I need to put whatever is returning inside the variable so I can see it if I need it. So in this case, I want to see the build year and I want to see it from outside that class. So it just makes sense I create a variable called, remember, the return type of this guy is int. So I'll just say int, and I'll come here, I'll just say, I can just give it something like b year. That's my variable name. So that means when this code gets run, it's going to return the build year and save. I'm now taking whatever is returning and putting it inside this variable. I'm going to do the same thing here. I'm going to say string. I think the other one was called um, show model name. So I'll just say name, which is a variable name I'm using. Then I'll say go to call the car object. You see here initialize the car object. Say car object dot, see, because it's public, I can see it. Model name, and it returns the string of model name. And now I'm storing whatever is returning. I'm storing it here. Then I can print it here. Now I can say system.out.print. I can say give me the B year and give me the M name. If I run this now, check this out. It says 2024 and Volvo. So what am I trying to say? I'm trying to teach two things. First of all, access modifiers. The only thing that I can see are these public methods. I can't see any of this private stuff. And then I talked about, okay, then how are you going to access this? How are you going to be able to see what's in here if you want to use it? We use methods. We create methods that we call getters and setters. So this is like a getter. A getter means get. I want to see it. And uh, typically, this is a getter and setter. The only difference is when you want to create a typical getter and setter, you use a naming convention, but it's doing the same thing. So it's the typical way you would name a getter, which is exactly what this thing is doing. Is just getting the model name is. In case you see it in someone else code, you just see the word get, and then so in this case we get. Sorry, starts with get, and then model, which is the name of the name of the variable itself. And you see IntelliJ is already telling me, and I'll say get build year. So this is a typical getter, but that also means I have to go back to my car creator class and change the name to what they are. So get, this will be get build name, and this will be get model. So it's the same thing. You see, it's the same thing. The only thing I just changed the name. So you could either do it the way I just did it or use the convention. You remember what convention means is what everybody does. All programmers do it a certain kind of way. And the convention is you just name it get the name of you say get and the name of the variable. But it's not compulsory. You can do it your own way. I normally, like I said, depending on what I have to do, most times I just give it a descriptive name of what I want. But yet again, if you're programming where you know you're going to program with other programmers, it's best to use conventions because the other programmers are not going to start thinking like, huh, why did you do this or what's going on? You just they're just going to look at, oh, this is a getter, this is a getter. That means with this method, I can gain access, so I can be able to see what is being defined in these private properties. How about the setter? Okay, first of all, so you see the getter is a method. A method is something that actually does something. And what these two methods are doing is they are returning something. Then if you're not returning anything, then you must make it a void. So you see here, we're not returning anything. We're just printing stuff. We're just printing color. So those are the two kind of return types we have. We have, the two types of method we have. We have a method that returns something and a method that doesn't return something. The method that returns something, you must give it the return type, which is int, string, float, whatever. You must. If it's not returning anything, you give it a void. Now let me show you something. You guys probably we've been doing it, but you guys didn't notice. If we go to car class, our main method, look, it's a method. Remember, we call it main method. We've been using our word main method. It's the same thing. Our main method has a return type of void, which means we're not expecting it to return anything. It's just supposed to do, but not return anything. Nova, just a minute. Nova, you can go into the picture. So you see, funny enough, we've been using this, but we just didn't pay attention to it. But it just means that this main method is not going to return anything. It's just going to do. It's just going to do whatever it finds here. I'm just going to do. I'm not returning anything. But here we have a method that says get model. So it's going to return a string. When you call it, whoever is calling it is going to get something back from it. So Constance has a question. Exactly. It sounds like overkill, right? Like, what? Why are you making life so difficult when
I
when I
just want
can
to know
just
why you
access
don't
it,
just make the
right?
properties
Well,
public
the answer
instead
to
of
that
making
is
a whole like get
we're going to come into that
methods,
because
a getters
object-oriented programming
methods to get
knows
the
certain
you
concepts.
know.
So let me go back to that. Uh, let me go back to that website I gave you guys to go through. which I'm definitely going to explain to you guys, but not today because I'm trying to break this down really easy for you guys. So let's see. Let me be sure. I don't know if they handled it here. Access modifiers, keyword recursion. Okay, so I think that will be somewhere in two. Yeah. So yeah. So when you go to object oriented two, we're going to see why do we make those kind of weird decisions. So Java or object oriented programming knows what we call Java oriented um, knows what knows what we call OOP concepts. And OOP concepts comprises of um, and what that means. Let me put it like this. So what is that? For you to be programming something object-oriented programming or to be using that concept of OOP, you have to write your software in a certain kind of way. If you're not writing in a certain kind of way, then you're not using OOP. You're not using object-oriented programming. And that's what we call object-oriented concepts. And object-oriented concepts, we have four main types. Four main things you must do if you are, if you want to say um, you're programming in OOP. Or I will not use the word four things. Four things. I will not use must. I'll say four things that your program needs to adhere to, and those are inheritance, uh, polymorphism, encapsulation. They kind of scattered it here, so I'll just say Java OOP concepts. We call that the concepts of OOP. So you see it easily. Let me use an image. Let's see. This is what it is. So we have encapsulation, abstraction, and inheritance and polymorphism. What you're asking about, Constance, falls under encapsulation. Remember, just think about the word encapsulation, capsule. I don't know if you guys know what like the word like I'm sure you guys know capsule. Capsule is like when we're kids, we have medicines that are capsules. So let me say medicine capsule. So these are capsules. So if I asked you what's inside this capsule, you that is drinking it, do you know? Do you even know the color? In most cases, you don't, and you don't care. You really don't care. You just want to drink it and let it do what it's supposed to do. That's what capsules are for. Capsules are like they hide the internal gymnastics. And you that want to use it, you don't care. You just want to use it and let it do what it's supposed to do. Another example of a capsule, remember the idea of a capsule is encapsulating the inner function of something. Another example of a capsule is also a car. So let's take a car for an example. So let's put this car. So a car that you guys see is also a capsule in a sense. And the capsule part of it is mostly the engine. The if you look under, there's a lot of mechanism working doing something under. But you as the driver, do you care? You don't care. You don't want to be. You don't even want to see this engine when you're driving. That's why they covered it. They encapsulated it because the user does not care. I don't want to be seeing engine. I just want to go inside and drive. I don't want to turn off the ignition. I don't want to know what happens when I turn on the ignition. I'm not interested. All I know is when I turn on the ignition, it should work. That is you as the manufacturer encapsulating some features or functions because the user does not care. The only thing the user cares is if I get into the car, if I turn on the ignition, it should turn on. The user does not care that, oh, if I turn on the ignition, water should move from here to there, the fire combustion should move from there to there. uh, no, I don't want to know. So to get back to your question, like I told you, programming, we are always trying to copy real life. Like it's a mimic of real life. The question is, why do you make these things private? Now, this is a very simple example, But in most cases, when you're writing code, there are most of these features that you see here or properties will actually be influenced or will be changed by other properties. For example, if this is a car, I could want to design a car that when you turn it on, the color will change. So that means in my setter, sorry, maybe I might have a function here that says, sorry, let me just give a typical example. I could say something like, I could do something like in my constructor, I'll create a constructor, public car, and I can create a whole logic. I can say, uh, if the year is greater than 2024, I can say then make the color is equal to yellow. And then I will say something like, okay, if that's not the case, I'll say, sorry, I'll say else. So if that's not the case, make the color equal to black. So, so you see, I have some kind of logic here. Sorry, I think I put the wrong thing. So build year. So I'm checking. If the build year is more than 2024, if it's greater than that, make it yellow. If not, black. So there's some kind of logic happening here. When you run this from outside the class, the person, the me that is calling it here, I don't want to know what's happening. I just want to know that when I create a new instance should be created. Now, if I make this color accessible, if I make it public, that means whoever is creating it can come here now and manipulate it easily. So check this now. I'm gonna come here now. I say car, and I say I say, oh, I have access to the color. You know what? I'm gonna give it my own color. I'm gonna say um, brown red. See, because I have access to it now, now I'm doing something else. Then I'll come here and I'll say I want you to print out car dot say car dot. You know we have this thing that gives us show color. Yeah, we had show color. So if I run this now, check out what's gonna happen. See, brown red. But me as the manufacturer, that's not what I don't want people to gain access to that. All they should just know is so if I made this now private again now, I'm just gonna make this private again. If I make it private, you see that the user cannot just mess up or adjust this color without going through the right channel. So I'm going to do this now. So now if I run this now, you see it's going to do something else. It's going to give us black because it's going through the right channel. This is like basically going through the engine. And maybe even if I want the user now to have the ability to change the color, I will do that through a method. But just look at this class now. There is no way you, as the driver of this car, can change this color. And the driver means you that is trying to use this class. You cannot change the color. So I am encapsulating some functions. I'm only giving you access to some functions, and I'm giving you access to some other functions. It's just like me saying, okay, I create a car, but then I create something. I make it possible for you to, I don't know, put your hand under the engine and remove something. No, I've blocked it. I've kind of like screwed a lot of things under the engine, and you cannot touch it. All you just need to know is when you get into the car, turn on the ignition. I don't want you to be going under the engine to mess up anything. That's why those places are encapsulated. And even you that is the user, you don't care. You don't want to go under the engine. You just want to start the car. So it goes two ways. So we encapsulate these features, I mean these properties because we don't want users or whoever is using the object to just change it without going through the right method or going through the right procedure. And like I said, you can make it public, but if you are programming using OOP concepts, then you want to do it the right way, which is you encapsulate your properties and make it accessible only through the right channel. It could also be that you want to, or only certain kind of people to be able to access it, like this model now that we have. We could be like, okay, if you want to access this model, you need to be, uh, you that is calling it from a get creator class, you need to adhere to certain rules. So that's why we probably have a get method, and then we create those if statements here that, okay, I'm going to check if the object has this, if it is on, so certain kind of things. So that way you control who has access to this private method. So to come back to kind of summarize it again, you're right, it's not by force. But if you want to program OOP the right way, you want to encapsulate certain things and only allow users to have access to things you as the programmer feel I want them to be able to access this. But these other things I don't want them to access. Just like the car designer. The car designer don't want you to be touching anything inside the engine because you could go and now start losing stuff and playing around with stuff and the car will stop working. So he covered it up with a bonnet. You understand? And trust me, when you buy a car, the when you buy a car, the car user, the person selling the car is not going to start telling you, okay, before on the car, open the bonnet, bring out this thing, turn this other place. Nah, you're gonna be like, what the hell? This is a sport car. I'm not touching anything. The only people that will be talking about those kind of things are car mechanics. But you, as the user, you're not interested. You just want to go into the car and turn it on. And the manufacturer is going to hide a lot of things from you because they don't concern you. They're only going to allow you to access things they want you to access in order for the car to function smoothly. Because if they allow you to access certain things, you might break the system or you might not use it the right way. So that's why we do this. It's not a must, but you encapsulate features. And I am going to explain all of these concepts because there's no way, it's not possible for anybody to explain OOP to you without talking about these four concepts. So some of you that have been doing other programming, I don't know if some of you have done OOP before. Definitely, if you've done it with C Sharp, if you've done it with Java, if you've done it with, if someone has taught you with what do you call it, with Python, you cannot talk about OOP without these four concepts. So if you know you want to program in object-oriented programming way, you want to adhere to these four concepts. And I'm going to discuss these four concepts in detail. So I hope that shed some light into the question because you're absolutely right. When I was learning programming too, I was like, why, guy, why? Why can't I just make this thing public? I want my life to be easy. I don't want to be creating methods. No, the idea is if you're designing OOP, you want to design like a professional. You understand? You don't want to build a car. You don't want to build a car that it's open. The bonnet is just open. The users can just come and just see everything and just before you know, kids will throw stone inside. Before you know, someone will take like my kids will easily take paper and make an airplane and throw it inside the engine. They will just mess it up. So you cover it, you encapsulate it. No, don't access that. That's not for you. All you need to do is go in, turn the ignition, and drive your car. So we also copy that in programming. We only make things available that we want users to be able to access. So we encapsulate stuff, and that's why we do it, or one of the reasons why we do it. So I'm gonna stop for now because I have an assignment for you guys. Because it's a lot of theory, and trust me, when it comes to OOP, the first thing you're gonna get is a little bit of theory because someone has to explain all of this. Sorry, before I go to the theory, I have to also show you guys how to set. So I told you guys about getters and setters. So here I showed you guys how to get a private property or to get something. But how do you set? What if I wanted to change the model and I cannot change it directly from here? So you create what we call setters. It's the same thing, but this time a setter does not have a return type because you're just setting something, right? So remember, if we're not returning anything, what keyword do we use? Let me see. Obi, can you remember? What keyword do we use when we're not setting something? Exactly. We use the void keyword. So remember, you're setting. You're not getting. You're just setting. I just want to change something. So we say public void, and then we use the keyword set. Say we want to set model. We say set model, and then something interesting happens.
Void keyword
For you to
is
set
void.
something, that means you that is setting it needs to be able to give me something, right? And you do that through the method through this. I can't remember what you call this, but we're going to pass parameters into the method, and we say first of all you have to think what is the type. So this model we look up what is the model type. The model is a string, so that means whatever you're giving me must be a string. So you put that then in the method here. So you say string, and then we say model name. So this is the name. You can give it anything, but I choose to say model name. And then when you now get it, so that means whoever is going to call this method must give us a model name. And then when the person gives us that model name, I'll now say model, this model, which is this one up here, that is private, that nobody can access. So that model is now equal to whatever the person gave us. So we're going to use the same now for build. We're going to do the same for, I think we changed for build year. So I'm just going to duplicate this code. I'll say set build year, and remember, build year is of type integer. So that means you must give me an integer type, and I'll call this build year. Let me just say build year inputs, and then since because we want to use it to adjust this build year, so we call that build year, which is the build year up there, is now equal to whatever the user gives us. So build year. Great. So let's see. So we use this to show color. Okay, yeah, let's set the color because we also have test for color. So say set color. Also create a setter for color. Set color. And remember, color is of type string, so that means you must give me a string. And I'll say color name. I'll call this one color name. And then remember, we have a private method, a private property called color up here that they cannot access. But and then we say color, sorry, not color name, color, which is up there, is now equal to the color that the person provides. Now let's see how we use that. So remember, this one, when we call this stuff, it gives us show color, right? So let's go back to that. So we see this prints the current color, and the current color at this point is pink. But even though it's pink, we also see that when you initialize it, it checks the build year and changes the color if the build year is greater than 2004. And you see the build year is not greater than 2004. That means it will set the color to black. So that means this is even absolute. This is not. It's never gonna make it pink, because the constructor will make it something else. So let's just get rid of that, and then let's just leave this logic here let's make it cool black. All right. So we have a show color, right? Now we want to change the color. So now take a look at what's gonna happen. So now we're gonna call show color, and then we're gonna so here we're gonna call show color, and what we know is going to be printed is what? Cool black, because build year is not greater than 2024. See, build year is 2024. So it's checking if build year is greater than 2024, and if it's not, it will make it cool black. So definitely the color is going to be cool black. Now we also now going to say car. So after we call the show color, we're going to call the car object again and say now we want to change the color. So we have our setter there. And remember, the setter that we just created, look at it, it says you must, since you're trying to set, you must give us a color name of type string. So now we'll call it cool pink. Now when we call it cool pink, we're going to call this method again that says show car to also get to see if this cool pink was actually assigned. Now check this out. I'm going to run it now, and voila. The first time it was cool black, which was this one, and then we now set the color using the setter, and we assign it to be cool pink. And remember, it does not return anything. It's a void. It acts, and as you can see, let's go back there. You see, it doesn't return anything. It just sets the color to the name to whatever you give it, and that's exactly. what happened here, we gave it a color called pink. And we did that through the parameter, and then we called show color again, and then it now told us, showed us that, oh, the color has changed to cool pink. So what am I trying to show you guys? This is a method on how to set stuff. Remember, you can use different names for this. We can call this any name we want. Now we're using set color. You can call it whatever. It will work. But if you want to follow conventions, because you're trying to change properties up here, we normally use the word setters and getters. So if you hear the word setter, getter, if I even use that word, oh, we can create a setter and getter. That's what they mean. You can create a method that you can use to set the property and that you can use to get the property. So remember, setter, getter. Programmers do that a lot. Oh, I can just create a getter. I can just create a setter. That's what they mean. I'll create a method that I can use to set the private property. So that's it. So I want you guys to know how to do these two things. So setting, you use void because you're not returning anything. Whenever you're returning something, you use the type that you're expecting to come back when someone calls it. So I'm gonna give you guys an assignment now because I have given you guys a lot of theory and it is quite normal to get a little bit of theory when you're diving into object-oriented programming, but I do intend uh, to back it up with quite uh, some lab sessions as we go on. So I have a couple here. Let's see which one are we gonna do. So I think I'm gonna give it to you guys as an assignment, so you guys can play around with it. So this one says write a Java method to find the smallest number among three numbers. So this is just typically, I want you guys to practice how to create methods. So of course you're going to create a class, and when you create a class, inside that class you have to create a method, and the method would have, you have to be able to input the first number, and input the second number, and input the third number, and what it should return to you would be uh, the smallest of the three numbers. So the smallest would be 25. So in this case, if you input in the method um, um, 25, 37, and 29, what it should return to you would be 25. Now I'm going to solve this one just so you guys don't get knocked off, but you guys will have to do the rest. Now, what I'm going to solve, I'm not going to solve it per se, but I'm going to show you how to add these three inputs. So a method that is taking three inputs, what does that look like? Look at this. The method is going to take three inputs and is going to return an output. So please, someone has to tell me, what will be the return type of this stuff, of this code? Let's see, constants. What will be the return type of this? Um, Remember, void does not return anything. Yes, it could be int. If you want to be specific, maybe not even int, because you see, I kind of did a trick stuff here. It's a point. There's a point there. Int does not return a point, so this is probably going to be a float. But of course, the inputs are
Point.
ints. You see that? So
Uh,
what I just want to show you guys is I want to show you guys how to
So
create
int.
a method that accepts three uh, parameters, but I'm not going to solve it. Uh, then you guys will do that. So let's just give you an example of this. So I'm gonna write a program now. So I'm just gonna come up here, say new class. So I'll give it a name. What would I give it? I'll give it a name smallest number. I'll say smallest number. That's the name of my class. So you see, this is the class. And now that means yeah, it's actually a blueprint. Then I want to create a method that takes three numbers. So I'm gonna say what name would I give the method? So this returns the smallest of three. So I'll give it a name called, I'll say public because I want it to be accessible. Public. Of course the return type is what? Float. Because you see I've put a point here. It should have a point. But for simplicity, you guys can start with int. I'll say you guys start with int, and when you solve it, then you can go to float. But let's say int. Let's leave it at int for simplicity. So public int, then I'll give it a name. What is it doing? It's returning the smallest out of three. I'll say smallest out of out of three. Then this is the interesting part. It takes three values. This is the first one, second one, and third one. So that means I'll have int. I'll call this first value, and then int again, second. This is first. Sorry, first value. Say second value. Of course, you can give it any name. You remember this is just a variable name, and then another int, third value. And now you have to return. You have to do something here. Remember, it says you have to, what we expect is the smallest out of the three. So that means you have to return a value. So I'm just going to put return 0 or return, yeah, I'll just say return 5. But here, you guys have to write some logic that is going to figure out what is the smallest around of these three. And when you find the smallest of these three, that is what you have to return. You have to return either, it's either going to be first value when you have done your logic, or it's going to be the second, or it's going to be the third. But you have to do some kind of check in here. So you have a question? Yeah, or whatever. You can use a switch case, however you think you can solve it. You understand? I didn't want to say if because I don't want to make you guys think a certain kind of way. Just think of it like a problem. Some people might want to use if, some might want to use switch. Just yeah, but
Yeah,
it's
by
gonna
logic,
be
you
some
mean
kind of
using
logic.
like
Yeah,
an if statement,
just
right?
do what comes to your mind. Now, yeah, so that's what this would do. How what we expect. So that means if I came in here to my, I'm gonna use the car creator because that's where I have my main method. If I came in here and I created a new instance of, remember how do you create a new instance? Say the name of the class, smallest number, I'll, then I'll give it a variable name. I'll just call it sm is equal to new. You have to use the new keyword, new instance of smallest number. So now I have a new object. And remember, I don't have a constructor, and that's fine. Why? Because Java will create one for me, and I don't need a constructor because that's not part of what the assignment is about. The assignment is about creating a method, and you have created a method. So don't worry about the constructor. Java will take care of it. So when I create this constructor, you would now see that when I go to my calculator class, I can now say sm dot. Ah, check. That's my method. And it's expecting three values, first, second, and third. So now I can say the first one could be 45, the second one I'll make it 2, and the third one I'll make it 8. And then that means that I have to come in front here and say, and create a variable which I'm expecting to be int. Remember the return type is int. So I'm expecting an int. I'll give it a name. The name will now be smallest number because that's what I'm expecting to come back is equal to this. So that means when I run this, when this method is run, what I'm expecting to come back is the smallest number. And then I can print that out here. System.out out dot print ln, I'll say smallest number, uh, smallest number. So if I run this now, it's gonna work. So it's giving me 8, but my logic is wrong because in here I just returned third. It's not doing any logic to see if the three which of the three is the smallest number. You understand? So that's left for you guys to create the logic. But I just wanted to make you guys to see how you can add more than one uh, parameter to a method. Yeah. So I'm just gonna do this a print. This is actually quite easy. These are quite easy stuff. Uh, if you figure it out. So I'm just gonna paste it here in the group chat. So we have others here, quite a couple of them. So this would kind of make you guys get familiar with working with methods because yeah, they're very important. Methods are very powerful, very important, and we want to practice them. All right, so that'll be it for today. Thank you guys so much. Um, Please go ahead and make sure you read through this stuff. Let me get the page again back online. Let me see. Just give me a minute. Trying to get the. I think I did something to my page. All right, I got it. This. So please, please, please read this stuff through. There's no how you're gonna read it through. You're not gonna have questions for me, or of course, you can just listen to the whole training. But by the time I'm getting to the end of OOP, you should have questions. You understand? The beauty of reading this stuff is it makes what I'm explaining to you a lot easier. You'll be like, oh yeah, I saw that. I talked. I remember you talked about method. Yeah, I read about it. Oh yeah, it's true. We talked about return types. And if you create a method, you can return integer. You might even see stuff that I'm not talking about. Like, okay, what about this? I read about this. What do you think it's doing? You see, so it just gets you kind of like more up to speed because these concepts are. It's just right now. I'm just trying to teach you guys how to. Remember, we're using the an analogy of learning a new language, right? Which is exactly what we're doing. We're learning a language called Java. So now, what I'm trying to teach you guys is how to write songs, right? How to write songs. If you want to write songs, you want to write it in a certain way. You want to follow certain principles. You want to follow certain you want to be able to write like when I mean write songs, I'm talking about writing songs like what do you call it? Song, or write music. I think that's what I mean. Write music. So what they call this music lines. I don't know how to write music myself. Music notes. Yeah. So so you want to know how to use this to write something beautiful. But that's what we are learning. So of course, it's gonna be tricky at first. Like, oh, I don't understand this, but please be consistent. Just don't give up. Just keep going through it. And you going through this, you might go through it the first time you don't understand a lot, but because you went through it, when I'm now explaining it, it will start making sense. Like, oh, okay, I read something like this, or you might actually have questions that you want to be like, okay, I read something like this. Now you're saying it. Is it the same? I don't understand it. So that's why I think it's important to read it. Are there any questions so far? All right, no questions. So thank you guys so much. Um, Please do the assignments. If you have any questions, Ifine yourself as well. I know you've been programming for quite a while. You might have questions that are a little bit more advanced because of you know some things already. Just ask it, and I'll do my best to give you the best answers I can. Okay? And if you learn to use object-oriented programming, if you learn this concept, it's going to open the doors to a beautiful career in whatever language you want to learn. If it is Java, if it is C Sharp, if it is Python, even TypeScript, JavaScript, all are adopting object oriented programming. The concepts are the same. And hopefully, you will be able to pick a career path for yourself. So it is very important. That's why I'm really hoping none of you will miss these classes, especially this block of classes that we're talking about OOP. They are sometimes a little bit difficult to grasp at first, but if you keep up with the classes, don't miss the classes, you would not miss out anything. There'll be no gap in your learning it. Okay? Thank you, and you guys have a lovely weekend. All right. Thank you too. You're welcome. Bye. All right. Bye, guys.